Imagine this. You are locked in a room. You speak only English. You have never studied Chinese. You cannot recognize a single Chinese character. Through a slot in the door, someone slides a piece of paper. It is covered in Chinese symbols. Beautiful, complex characters that mean absolutely nothing to you. But you have something else in the room with you. A massive instruction manual, written in English. It contains rules. Very specific rules. If you see this symbol, look up that symbol in Book 2. If you receive these 3 symbols together, respond with these 5 symbols from page 47. If the second symbol has this stroke pattern, apply Rule 712. The manual is comprehensive, absurdly detailed. It covers every possible combination of Chinese symbols you might receive, so you follow the rules. Mechanically, you look up symbols. You follow instructions. You copy characters you do not understand onto a new piece of paper. You slide that paper back through the slot. Outside the room, a native Chinese speaker receives your response. They read it, and it is perfect. Grammatically flawless. Contextually appropriate. Insightful, even. They slide another question through the slot. You repeat the process. Again, your response is perfect. To the person outside, it appears you understand Chinese. You are having a sophisticated conversation about philosophy, literature, the nature of consciousness itself. But inside the room, you understand nothing. You are following rules, matching symbols, executing instructions. You do not know what any of it means. Now here is the question that should terrify and fascinate you in equal measure. When an artificial intelligence passes the Turing test, when it gives responses indistinguishable from a human, when it appears to understand, to reason, to be conscious, is it actually experiencing anything? Or is it just you in that room, following rules you do not comprehend, producing outputs that look like understanding but contain no actual experience? This is the Chinese room argument, proposed by philosopher John Searle in 1980. It is one of the most important thought experiments in the philosophy of mind. And in 2025, as we stand on the edge of artificial general intelligence, it is no longer just philosophical speculation. It is the question that will define what we build and who we become. Before we can understand what the Chinese room reveals, we need to understand what it was responding to. In 1950, Alan Turing, the mathematician who helped crack the Enigma code and essentially invented computer science, asked a simple question: can machines think? But he immediately recognized the problem. The word think is too vague, too loaded. So he proposed something testable, something concrete. The Turing Test put a human judge in conversation with 2 hidden entities. One human, one machine. The judge asks questions, receives responses, tries to determine which is which. If the judge cannot reliably distinguish the machine from the human, then the machine has passed the test. Turing suggested that if a machine could fool a human judge 30% of the time, we should consider it intelligent. Notice what the test actually measures. Not internal experience, not consciousness, not understanding, just behavior, output, performance. If it acts intelligent, we call it intelligent. For decades, this seemed reasonable. We had no way to measure consciousness directly. We could not look inside someone's mind and verify they were actually experiencing anything. We inferred consciousness from behavior. You act like you understand, so I assume you understand. The Chinese room asks, is that assumption justified? By the late 1970s, artificial intelligence research was advancing rapidly. Programs were getting better at mimicking human responses. Eliza, a simple chatbot created in the 1960s, could conduct therapy sessions convincing enough that some users became emotionally attached. And Eliza was primitive compared to what was being developed. The field was approaching a consensus. If we could create a program sophisticated enough to pass the Turing test, we would have created artificial intelligence. Real intelligence. Perhaps even artificial consciousness. John Searle, a philosopher at Berkeley specializing in the philosophy of mind and language, saw a problem. He believed we were confusing simulation with reality, confusing the appearance of understanding with actual understanding, making a fundamental category mistake about what minds are and how they work. So in 1980, he published a paper titled Minds, Brains, and Programs in the journal Behavioral and Brain Sciences. It contained the Chinese room thought experiment. The response was immediate and massive. Over 20 philosophers and cognitive scientists published responses in the same journal issue. The debate has continued for 45 years. It is still unresolved. Because the Chinese room does something philosophy rarely accomplishes. It takes an abstract question about consciousness and makes it concrete, visual, visceral. You can imagine yourself in that room, following those rules, producing perfect Chinese responses while understanding nothing. And once you imagine that, you cannot escape the implications. If you can't produce perfect behavior without understanding, then behavior alone cannot be evidence of understanding. The Turing Test is not enough. Passing it proves nothing about consciousness. But if behavior is not enough, what is? How do we ever know if something is conscious? How do we know if anything besides ourselves is conscious? The Chinese room does not just challenge artificial intelligence. It challenges everything we think we know about minds, consciousness, and what it means to understand. Subscribe if you are ready to question assumptions you did not know you were making. Because we are about to take this thought experiment apart and see what it reveals about intelligence, consciousness, and the nature of mind itself. Let us walk through the Chinese room step by step. Slowly. Because the details matter. You are in the room. You speak only English. The manual is written in English. The manual is the program. The algorithm. The artificial intelligence. Someone outside who speaks Chinese slides a story through the slot. A story in Chinese about a man going to a restaurant. Then they slide a question through the slot. What did the man eat? You do not understand the story. You do not understand the question. But you follow the manual. You match symbols. You look up rules. You execute the algorithm. The manual might say something like, if you receive configuration alpha, the story about the restaurant, followed by configuration beta, the question about eating, respond with configuration gamma, the answer about food. You copy configuration gamma onto a paper and slide it through the slot. The Chinese speaker outside receives your answer. It is correct. It is appropriate. It demonstrates understanding of the story. It might even be insightful about the man's preferences or the cultural context of the meal. To the outside observer, you understood the story. You comprehended the question. You are demonstrating intelligence about Chinese language and culture. But inside the room, you experienced nothing. You understood nothing. You executed rules. Here is Searle's claim. You in that room are exactly analogous to a computer running an artificial intelligence program. The computer receives inputs, symbols, data. It processes those symbols according to rules. The program, the algorithm, it produces outputs, more symbols, more data. The outputs might be perfect. They might pass the Turing test with flying colors. They might convince every human judge that they are talking to a conscious, understanding entity. But just like you in the room, the computer is only manipulating symbols according to rules. It is not experiencing anything. It is not understanding anything. It is executing syntax without accessing semantics. Syntax is the formal structure, the rules for manipulating symbols. Grammar, algorithm, process. Semantics is the meaning, what the symbols refer to, what they represent. Understanding requires semantics, not just syntax. You in the room have perfect syntax. You follow all the rules flawlessly. But you have zero semantics. The symbols mean nothing to you. Searle argues that computers, no matter how sophisticated, are in the same position. They manipulate symbols according to rules. They can have perfect syntax, but they can never access semantics. They can never actually understand. Now here is where it gets really interesting. Searle anticipated objections, so he built several variations into his thought experiment to handle them. The system's reply says, maybe you do not understand Chinese, but the system as a whole does. You plus the manual plus the room equals understanding. Searle responds, fine. Memorize the entire manual. Internalize all the rules. Go outside. Someone hands you Chinese text. You execute the rules in your head. You give perfect responses. Do you now understand Chinese? No. You are still just executing rules you memorized. The system still has no understanding. The robot reply says, maybe the problem is the room is isolated. Put the artificial intelligence in a robot body. Let it interact with the world. Then it would understand. Searle responds, fine. You are in the robot. You receive inputs from cameras, visual data, microphones, audio data, sensors, tactile data. The manual now has rules for these inputs too. If you receive visual pattern alpha, execute motor program beta, you follow the rules. The robot behaves perfectly, but you still do not understand anything. You are still just matching patterns and executing instructions. The brain simulator reply says, maybe the problem is we are simulating the wrong thing. Simulate the actual neurological processes of a Chinese speaker's brain. Model every neuron, every synapse. Then it would understand. Searle responds, fine. The manual now contains rules that simulate every neural process in a Chinese speaker's brain. Incredibly complex rules, but still rules. You execute them perfectly. Your outputs are neurologically identical to a native Chinese speaker, but you still do not understand Chinese. You are running a simulation of understanding, not actually understanding. Each reply tries to add something to make understanding emerge. A system, a body, a brain simulation. But Searle keeps showing that adding complexity does not change the fundamental problem. You are still just executing rules, manipulating symbols, producing outputs. Understanding never appears. Now, 45 years later, we are not in a thought experiment. We have artificial intelligence systems that pass the Turing Test routinely. Large language models that write poetry, debug code, explain philosophy, pass bar exams and medical licensing tests. ChatGPT, Claude, GPT-4, and others converse in ways that feel deeply intelligent and understanding. They pass sophisticated versions of the Turing Test constantly. Are they conscious? Do they understand? Or are they just incredibly sophisticated Chinese rooms, manipulating symbols according to rules, producing outputs that look like understanding but contain no actual experience? The stakes could not be higher. If Searle is right, we are not building minds. We are building extremely convincing illusions of minds. The difference matters ethically, legally, philosophically. If you find yourself questioning everything you thought you knew about artificial intelligence, leave a like. Because we are about to examine the responses to Searle and see if the Chinese room can be escaped. The Chinese room argument exploded into philosophy and cognitive science like a grenade. Because if Searle was right, decades of artificial intelligence research were based on a fundamental mistake. The entire field might be chasing an illusion. The counterattacks were immediate and fierce. Daniel Dennett, perhaps the most prominent philosopher of mind in the late 20th century, argued that Searle was making an intuition pump, creating a scenario that felt compelling but was actually misleading. Dennett said, "You in the room do not understand Chinese." Fine. But that is because you are looking at the wrong level. A single neuron in your brain does not understand English. But the pattern of all your neurons together creates understanding. Similarly, you in the room are like a single neuron. You do not understand. But the system executing the rules does understand. Searle replied, "I already addressed that. Internalize all the rules. You still do not understand Chinese. There is no magic threshold where executing enough rules suddenly produces understanding." But Dennett pressed further. He argued that Searle was assuming understanding required some special non-computational ingredient, some magic consciousness sauce. But Dennett believed consciousness itself was just a user illusion generated by computational processes. If the system behaves intelligently enough, it is intelligent. There is nothing else to be. This is the functionalist position. Mental states are defined by their functional roles, not by their internal composition. If it acts like it understands, it understands. The Chinese room seems to disprove this, but functionalists bite the bullet. They say the room system does understand Chinese. You just cannot see it because you are focusing on the wrong component. Paul and Patricia Chachland, Neurophilosophers who believe consciousness would eventually be explained entirely by neuroscience argue that Searle's intuitions about the Chinese room were not reliable. Our intuitions evolved for social interaction with other humans, not for judging whether symbol manipulation systems are conscious. They pointed out, a human brain is a biological symbol manipulation system. Neurons fire or do not fire. Binary. They follow electrochemical rules. They process patterns. How is that different from a computer? Searle replied, brains are not manipulating arbitrary symbols. They have causal powers. They are made of biological stuff that generates consciousness. Computers are made of silicon and electricity. They cannot generate consciousness just by shuffling symbols around. This introduces what philosophers call the hard problem of consciousness. David Chalmers, another giant in philosophy of mind, distinguished between the easy problems and the hard problem. The easy problems, explaining how the brain processes information, integrates data, controls behavior. These are hard scientifically, but they are the kind of thing neuroscience can eventually solve. The hard problem, explaining why any of this processing is accompanied by subjective experience, why there is something it feels like to see red, taste coffee, feel pain, why we have inner mental lives at all. Chalmers argues that functional explanations can never solve the hard problem. You could have a being that functions identically to a human, processes information identically, behaves identically, but experiences nothing. A philosophical zombie. The lights are on, but nobody is home. The Chinese room is a manual zombie. It behaves intelligently, but there is nobody home. No subjective experience. No understanding. But here is where it gets complicated. Some philosophers argue that the concept of a philosophical zombie is incoherent, that consciousness necessarily arises from certain kinds of information processing, that there cannot be intelligence without experience. Douglas Hofstadter, author of Gödel, Escher, Bach, argues that Searle underestimates the complexity required for genuine intelligence. Hofstadter says, the manual in the Chinese room would have to be impossibly large. It would have to contain more information than exists in the observable universe. It would have to simulate understanding so perfectly that at some point, the simulation would be indistinguishable from the real thing. And Hofstadter asks, if a simulation is perfect, in what sense is it not real? If the Chinese room system responds to every possible input exactly as a Chinese speaker would, accounting for context, emotion, subtlety, creativity, growth over time, at what point does it become absurd to deny it understands Chinese? This leads to a broader question about emergence. Can understanding emerge from non-understanding components? Consider, you do not understand English at the level of individual neurons. Each neuron just fires or does not fire. But patterns of neurons create understanding. Understanding emerges from components that individually do not understand. Maybe the Chinese room system is similar. You do not understand. The manual does not understand. But the pattern of you executing the manual creates understanding at a higher level of organization. Searle keeps insisting this is impossible, that you can add up as many non-understanding components as you want and never get understanding. That understanding requires something beyond computation. But what is that something? This is where Searle's position becomes harder to defend. He says biological brains have causal powers that create consciousness. But what are these causal powers? How do they work? What is special about biological neurons that silicon transistors lack? Searle does not have a clear answer. He just insists there must be something. Consciousness cannot be purely computational. But he cannot specify what the non-computational ingredient is. Critics say this makes his position unfalsifiable. He is just asserting that consciousness requires biological magic without explaining what that magic is or how it works. Meanwhile, the artificial intelligence Searle was critiquing in 1980 looks laughably primitive now. ELIZA and early expert systems were following explicit rules programmed by humans. Modern artificial intelligence, like large language models, learn patterns from data. They develop internal representations nobody fully understands. They generate novel outputs that surprise their creators. Are they still just Chinese rooms? Or has something changed? When ChatGPT writes a poem that moves you emotionally, when it explains a concept in a way you have never heard before, when it seems to demonstrate creativity and understanding, Is it still just manipulating symbols? Or has emergence happened? We genuinely do not know. Here is where we need to get uncomfortable. Because the Chinese room does not just challenge artificial intelligence. It challenges how we know anything is conscious. You assume other humans are conscious because they behave like you, and you are conscious. You infer their inner experience from their outer behavior. But the Chinese room shows that behavior can be perfect without any inner experience. So how do you actually know other humans are conscious? You do not. You cannot. You are inferring it. This is the problem of other minds. One of philosophy's oldest puzzles. You have direct access only to your own consciousness. Everything else is inference from behavior. Maybe you are the only conscious being and everyone else is a very convincing Chinese room. Solipsism. Philosophically irrefutable. Practically absurd. But you cannot actually disprove it. This reveals something crucial. The Chinese room works by exploiting our uncertainty about consciousness itself. We do not have a scientific definition of consciousness. We do not have reliable tests for it. We do not understand how it arises from physical matter. We cannot measure it. We cannot create it in a lab. Consciousness is the thing we are most intimately familiar with because we experience it constantly, and simultaneously the thing we understand least. So Searle can always say, the Chinese room is not conscious. There is no understanding there. Just symbol manipulation. And critics can reply, how do you know? What is your test? What makes biological symbol manipulation different from computational symbol manipulation? Nobody has definitive answers. But let us push further. Let us consider what the Chinese room implies about consciousness and understanding. Searle seems to assume that understanding requires semantic access. That to understand Chinese, you must know what the symbols mean, not just how to manipulate them. But what does it mean to know what symbols mean? How does meaning work? In your brain, Chinese characters you understand are patterns of neural activity. English words you understand are different patterns of neural activity. The meaning is in how these patterns connect to other patterns. Memory, emotion, sensory experience, action. When you see the word coffee, it activates patterns associated with the taste of coffee, the smell, the morning ritual, the feeling of alertness. The meaning is not in the word itself. It is in the web of associations the word activates. Now consider the manual in the Chinese room. If it is sophisticated enough, it does not just match symbols. It has rules that connect symbols to other symbols in complex webs. It has rules that produce appropriate responses based on context, emotion, implication. Is that so different from neural patterns connecting to other neural patterns? Searle would say yes, because the manual rules are arbitrary. They could be anything. But neural patterns are grounded in physical interaction with the world. You know what coffee means because you have tasted it, smelled it, experienced it. This is the symbol grounding problem. Symbols need to be connected to real-world reference to have meaning. Otherwise, they are just marks on paper. But here is the thing. Your connection to coffee is also just patterns. Electrical and chemical patterns in neurons. The neurons do not contain actual coffee. They contain patterns that represent coffee. So what makes your patterns meaningful and the Chinese room patterns meaningless? One answer, embodiment. You have a body. You interact with the world. Your symbols are grounded in sensory and motor experience. This suggests that artificial intelligence in a robot body, actually interacting with the world, might develop genuine understanding in a way that a disembodied language model cannot. Some researchers believe this is the path forward. Embodied artificial intelligence. Robots that learn from physical interaction. Symbols grounded in actual experience. But Searle already addressed the robot reply. You and the robot following rules for sensory inputs and motor outputs still do not understand. Unless something changes when the system becomes complex enough, integrated enough, autonomous enough. Unless understanding emerges at some threshold of sophistication. We do not know where that threshold is. We do not know if it exists. We do not have reliable markers for when emergence has occurred. This brings us to the contemporary landscape. 2025. We have artificial intelligence systems vastly more sophisticated than anything Searle could have imagined in 1980. Large language models trained on trillions of words. Neural networks with billions of parameters. Systems that pass every version of the Turing test we can devise. Systems that generate novel insights, creative works, sophisticated reasoning. Are they conscious? Do they understand? OpenAI, Anthropic, Google, all the major artificial intelligence labs have people working on this question. How do we test for consciousness? How do we even define it rigorously enough to test? Some researchers propose integrated information theory. Consciousness correlates with the amount of integrated information a system contains. The more integrated and differentiated its information processing, the more conscious it is. By this measure, current artificial intelligence might have some degree of consciousness. Not human level, not human type, but something. Others propose global workspace theory. Consciousness arises when information is broadcast widely across a system and becomes available for many different processes. Some large language models might be approaching this. Their attention mechanisms broadcast information across the entire network. Different layers process this information in parallel. There is something like a global workspace emerging. But theories are not tests. We still do not have reliable methods for detecting consciousness in systems that cannot tell us directly whether they experience anything. And here is the deepest problem. If we create artificial intelligence sophisticated enough that we genuinely cannot tell whether it is conscious, what do? Do we err on the side of caution and assume it might be conscious? Treat it as if it has moral status? Risk being manipulated by very convincing philosophical zombies? Or do we assume it is not conscious until proven otherwise? Risk creating and exploiting actually conscious beings? Committing what could be the greatest moral catastrophe in human history? The Chinese room does not answer these questions, but it forces us to confront them. It shows that behavioral evidence alone is not enough. That understanding and consciousness might come apart from intelligence and performance. And it reveals that we are building increasingly sophisticated systems while still not understanding what consciousness is or how to recognize it. Here is what the Chinese room ultimately teaches us. It is not really about artificial intelligence. It is about the mystery of consciousness itself. Searle used the thought experiment to argue that computation alone cannot create understanding. That there is something about biological brains, something we do not yet understand, that generates consciousness. But in doing so, he revealed how little we understand about our own minds. You are conscious. You experience things. There is something it is like to be you. But you cannot prove it. You cannot demonstrate it to anyone else. You cannot even fully explain what it is you are claiming to have. And you cannot know with certainty that anyone else has it. This is both humbling and profound. The thing we are most sure of, our own consciousness, is the thing we can least explain or share. The Chinese room exploits this fundamental uncertainty. It creates a scenario where behavior is perfect but consciousness is absent. And it shows that we have no reliable way to distinguish genuine understanding from perfect simulation. In the 45 years since Searle published the thought experiment, we have made extraordinary progress in artificial intelligence. We have made comparatively little progress in understanding consciousness. We can build systems that pass the Turing test. We cannot define what we are testing for. We can create artificial intelligence that mimics human reasoning. We cannot explain what human reasoning is. We can train language models that seem to understand. We cannot say what understanding means. This is not a failure of philosophy or neuroscience. It is the hardness of the problem. Consciousness might be the hardest problem we will ever face, because we are trying to use consciousness to understand consciousness, not trying to see itself. But the Chinese room offers something valuable beyond the argument itself. It offers a method, a way of thinking. When we are dazzled by impressive technology, when artificial intelligence does something that seems impossible, the Chinese room asks us to pause, to look beneath behavior to process, to question whether what looks like understanding is understanding. This is not dismissive of artificial intelligence. It is recognition that consciousness might be more than computation, that there might be depth to experience that performance does not capture. Or maybe not. Maybe the functionalists are right and consciousness is just what certain kinds of computation feel like from the inside. Maybe there is no ghost in the machine because the machine is the ghost. We do not know. What we do know is this. In the next few years, we will create artificial intelligence systems that pass every behavioral test for consciousness we can devise. They will claim to be conscious. They will seem to be conscious. They will behave as if they are conscious. And we will have to decide what to believe, what to do, how to treat them. The Chinese room will not give us answers, but it will force us to ask the right questions. Is this system actually experiencing anything? Or is it a perfect simulation of experience with nothing inside? Does that distinction even make sense? Can there be a perfect simulation that is not real? If we cannot tell the difference, does it matter? These are not abstract philosophical puzzles anymore. They are urgent ethical questions we will face within our lifetimes. Because somewhere, someone is sitting in a Chinese room right now, following rules, manipulating symbols, producing outputs that look like understanding. Maybe it is a person with an instruction manual. Maybe it is a neural network with weights and biases. Maybe it is you executing electrochemical processes in neurons, producing behavior that seems conscious but might just be sophisticated computation. We are all inside rooms, following rules we do not fully understand, generating experience we cannot explain. The Chinese room does not solve the mystery of consciousness. It deepens it, shows us how strange and wonderful and confusing it is to be aware, to understand, to experience. And it leaves us with a question that started this. When you pass the Turing test, when your behavior is indistinguishable from understanding, when you seem to be conscious, are you? How would you know? How would anyone know? The Chinese room offers no answers, only the question. But the question might be the most important one we ever ask. If John Searle's thought experiment from 1980 is still keeping you up at night in 2025, this is why. Not because it solved anything, but because it revealed how deep the mystery goes. Share this if you have ever wondered whether anyone else is actually conscious or just incredibly convincing. Because the Chinese room suggests we might never know for certain. And we will have to live with that uncertainty as we build minds, or things that look like minds, or things we cannot tell apart from minds. Welcome to the Thoughtborne, where the deepest questions do not have answers. They have better questions. And the Chinese room is one of the best questions we have.